Dear students, welcome and thank you for tuning in. We are continuing our discussion about corrosion for the biomaterials class. We're going to define now what is corrosion and what is the corrosion theory. The definition of corrosion is a method by which metals and alloys return to their unrefined, naturally occurring form, which is ores and minerals. In nature, metals such as iron, nickel, zinc, aluminum, they will be in a specific form. So they can be something we call oxides, sulfides, and carbonate. And what we mean by that is that the metal will have bonding with either oxygen for oxides and with sulfur for the sulfides and with carbon for the carbonates. Atoms, they can't be found in their pure form in nature. They have to be combined with either oxygen, sulfur, or carbon or other elements, but this is just to show you what does it mean to go back to their natural form. The natural form is the form in which that metal is in combination with either oxygen, sulfur, or carbon. This state in nature, it is the most stable state. So when we find like nickel oxides, this is a very stable state in nature. In order to have nickel in its pure form or in its manufactured form, when the ores or the sulfides or the oxides get refined, it means that this natural and most stable state is reversed to produce the actual metal that we use in our daily lives and in our applications. This form of metal that we use in our application is less stable than the ore, because ore has the least energy and it's the most stable state. And if you remember from thermodynamics, materials are systems. They want to be in their lowest energy state. When we process ores and oxides, sulfides, and carbonates, we are going to give them energy in blast furnaces to become the metal that we want. This is an unstable state, and under certain conditions, the metal wants to go back to its natural stable and the state where it has the least amount of energy, which is the oxide and the carbonate and the sulfide. Given the right conditions and following thermodynamics driven forces, if you remember that we discussed something called Gibbs free energy, in which we have the driving force of any reaction to take place. Delta G, the Gibbs free energy, has to be negative for that reaction to be spontaneous. So under certain conditions, our metals, our refined processed metals, will tend to go through a spontaneous process to go back to its lowest energy state. So metals will revert to their lowest energy state and less ordered ore condition. And if you remember that we need to lower energy and increase entropy, that's thermodynamics. So in conclusion, corrosion is a process where metals wants to go back to their lowest energy state and the less ordered condition they like to be in, which is the ore condition. In order to create metals for our applications, we need to give energy to create our refined metal. So I hope this is clear. So corrosion is a spontaneous process where metal wants to go back to their naturally occurring, less ordered, least energy state condition. We have a theory of how this happens. We call it the corrosion theory. Corrosion is the primary means by which metals deteriorate and break down. Metals corrode in contact with a lot of materials: water, acids, bases, salts, other solids, other liquids, other chemicals. They can also corrode if they're exposed to gas, like acid vapor, formaldehyde gases. Now, all of these things that metal get corroded, if they are in touch with, they form a condition or they create an environment that corrosion is promoted. And we need to understand that. We need to learn more about this. What does that mean and how does it work? So corrosion is not a mystery. We need to understand the process and the environment at which it happens and why this is happening because of all these other materials around it. So the best known case is that the rusting of steel. And what happened is that we would like to identify that corrosion process are usually electrochemical in nature, which means there is an electrical aspect and there is a chemical aspect to it, having the essential features of a battery. So if you remember, if you think about physics, a battery is a unit or an element that it has electrons stored in it, and this battery has an anode and the cathode sides. And if you connected the anode with the cathode with a wire, electrons will pass through, and then energy will be given or and transmitted to whatever application you want to do. So we want to keep in mind that corrosion is an electrochemical process. So electrical process will come from the fact that we have anodes and cathodes and electrons. And chemical, there should be a chemical reaction that's happening somewhere that will create and result in corrosion. Here's a theory. When metal atoms are exposed to an environment that contains water molecules, they will give up electrons. Now we have our electrons free, and the ions themselves, the atoms of the metal themselves, will become positively charged because we've lost electrons. The positively charged ions are going to create an anode, and the electrons, because of water, they will move, and this movement is going to lead them to go to another place where create a cathode location. We have metals, they lost electrons, and they become positive. We have loose electrons, and we have water that is immediate, just like a wire connecting them together. All of these elements will provide an electrical circuit. It's complete. This effect can be concentrated locally to form a bit and or sometimes a crack because of this process, because metals are dissolving because they're losing electrons and they're getting chemical reactions with other elements, which is OH minus. So because of this process, we're creating a bit, a bite, whatever you want, a bite, and that bite will create a crack, or it can extend, and that crack can extend across a wide area to produce general wastage of the metal itself. So we are losing our metal. Now, localized corrosion that leads to biting, or may provide sites for fatigue initiation. That's why we don't like corrosion, and we try to avoid corrosion. We try to use metals that they are resistive to corrosion inside the human body, because they will be susceptible to fatigue and then failure at the end. Corrosive agent, also like seawater, may lead to generally enhance the growth of the fatigue crack. And inside the human body, we have salts, we have water, so the environment is ready for the metal to corrode. I want to keep in mind that we have something called the galvanic series. So all metals exhibit tendency to oxide, which is the process of corrosion, some more easily than others. Tabulation of the relative strength of this tendency is called the galvanic series, and we're going to explain it and show it in more details. Thank you for watching. Until next video.